Greetings and welcome, friends. We're taking a look at 2007 Necap question number 18. And back in its day, all of our students managed to get this question wrong. Congratulations, friends. And only 10% of the state of Vermont's juniors were able to get this question right. So this clearly is a question of challenge. Not that it necessarily should be. I think there's just some difficulty in maybe understanding it in some ways. It says, Gary, okay, well right there, that's of course why kids were confused. Why is a snail spinning this at all? Can he somehow accomplish an initial velocity on said arrow to get it to even spin? I don't know. So Gary will spin the arrow on each spinner once and record the sum of the two numbers. All right, the arrows land on. I guess I made it sound like I finished that sentence earlier. What is the probability that the sum of the two numbers will be prime? So we got to first figure out what are prime numbers. So prime numbers is any number whose factor is 1 in itself. So there's only two factors. And 1, the number 1, happens to not be prime. So other prime numbers would be like 2, 3 is prime, 4 is not prime because 1 and 4 and 2 and 2 go into it, right? 5 is prime, 7 is prime, and the next prime number would be 11, but I don't think we'll even need it because the highest sum I can get is 4 plus 4 is 8. So those are the prime numbers I'm going to look for. And now let's figure out, okay, he's going to record the sum of the two spinners. So the lowest number I could get on each is 1 plus 1, and I would have a sum of 2. The highest number I could get is 4 plus 4 and get a sum of 8. However, the likelihood of any sum is not necessarily equivalent. Because notice if I have a sum of 5, I could have had 1 plus 4, but I also could have gotten 5 by doing 2 and 3, or by doing 3 and 2, or by getting a 4 here and then a 1 there. So a sum of 5 actually has a far greater likelihood of occurring compared to the sum of 8. So it's not an equal chance that the numbers 2 through 8 are going to occur. So the best way to do this is actually to draw up, at least this is the best way I could think of doing it, is draw up a list of the possible outcomes of kind of a sample space. And there's not that many, there's only 16 possible outcomes. So what I'm doing here is kind of very systematically going through. So I could have rolled a 1 on the, or spun, sorry, a 1 on the first one, a 2 on the second one. That's what I'm meaning by these. So each of these pairs, I guess, in this table is a possible outcome. Oh, nope. And let's finish this off. 4, 1, 4, 2, 4, 3, 4, 4. So that's all possible outcomes for these spinners. Now let's consider the sums of these numbers. So let's see, 1 and 1 adds to be 2, 1 and 2 adds to be 3, this adds to be 4, this adds to be 5, 2 and 1 adds to be 3, 4, 5, 6, then that's 4, 5, 6, 7, and this is 5, 6, 7, and 8. So, which of these are prime? Well, 2 is prime, the 3's are prime. Actually, I want to point out that these actually occur in diagonals here. You can see all the 5's together. So 2 is prime, the 3's were prime, the 5's were prime, and the 7's were prime. So how many occurrences is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's see, the probability of spinning a some prime, I guess, is going to be 9 out of how many possible combinations were there to begin with? There was 16, and this fraction does not reduce. I could, however, if I wanted, write that as a decimal. Probability is allowed to be written as a decimal or as a percentage, so that's 0.5625, or I could write that as 56.25% likelihood. So yeah, there was some degree of complexity to this problem. Even if a student understood what the prime numbers were and even understood probability, they would have had to realize that 5s were more likely than the 2, and that 3s were more likely than the 2, but less likely than the 5, right? And it ended up being a little bit more complex. And I think the easiest way to do this was to draw that sample space. So, thanks for watching, friends. Bye-bye.